Okay, so similar to the balancing equations video, I felt the need to do a second video with a few examples on net ionic equations, coming up with not only the balanced reaction but also the net ionic equation as well. Sorry if my camera's a little crooked, it's just not cooperating today. So net ionic equations, again, we're looking for that net reaction. Overall, what is changing? This is kind of your proof, if you will, of the reaction that's occurring. So I have two examples here that I'm going to try to get through. And this first one here says that iron 3 acetate reacts with ammonium oxide. I'm going to go ahead and write the full equation and balance it before I move on to the net ionic. So first we have to translate all of our words into symbols. So iron 3 plus, don't forget that any charge applies to the ion in front there. Also charges are written at the top. Acetate ion, -1. Be sure to balance all compounds to 0 before you proceed on. So 3 plus -1 does not equal 0. I got to multiply that 1 by something to take care of this +3. In this case, a 3 will do it. Reacts with ammonium oxide. So again, +1 minus 2 does not equal 0. I need to multiply my +1 by a 2. This is a double replacement reaction, which means that all of my ions are going to switch partners. So my iron with his 3+ charge is now going to hang out with my oxygen and his 2-. These two, not something simple I can multiply to get those two to the same number, so we got to go to least common denominator. After that, that leaves the ammonium with the acetate, and those two are already good. Can you see that? Yes. Okay, cool. So all of my ions, or excuse me, all of my compounds are balanced to 0. So double check, extra special sure. Are you confident that every compound seen in your equation does in fact balance out to 0 charge? After that, we are going to balance number of atoms using coefficients. I'm going to keep my polyatomics together for ease of counting. That just makes life a little bit simpler, in my opinion. 1 iron on the left, 2 irons on the right, 3 acetates, 1 acetate, 2 ammoniums, and 1 ammonia, 1 oxygen, and 3. So, let's get to balancing. Different color pen here. This is as good a place to start as any. So let's put a 2 in front of that iron. That 2 is going to distribute, changing both my iron and my acetate. So 2 times those groups of 3 gives me 6. Those are good. Oh, but I need 3 oxygens. Let's put a 3 in front of there. 3 times 2 is 6. 3 times 1 is 3. Now over here, irons are still good. Oxygens are good. It's just those acetates. A 6 there. Fantastic. So now I have a fully balanced chemical equation. The next thing to do is to assign solubility to each of my compounds in this equation to see whether or not I make something that was not there before. So, iron acetate. We're going to go through each of our rules in turn until we find one that applies to that compound. Number 1, let's see, no group 1s, no ammonia. Rule 2, acetates are soluble. Means that my iron acetate here gets the AQ. It will dissolve in water. My next compound, ammonium oxide. Number 1, common compounds of group 1 and ammonium. Yay! So this guy is also soluble. This is common, where we have 2 aqueous substances on the left side, on the reactants side. Next is iron oxide. Let's see, nothing out of group 1, no ammonias, nitrates, acetates, and chlorates. Nope. Binary of a halogen with a metal. Well, I have a metal, but no halogens. This one involves sulfate. Still doesn't help. Here we go. Oxides are insoluble unless it's attached to a group 1 ion. Iron, totally not a group 1 ion. So this guy is my solid. He's the one that will not dissolve in water. Last is that ammonium acetate. I got 2 rules for him. It's an ammonium ion and an acetate. So this guy literally jumps into solution. I use that in my crystal tree demo. I think I do anyway. It stinks to high heaven sometimes. That's alright. So, This is your complete balanced equation. I have all of my compounds zeroed out, the positives and the negatives. I have the same number of atoms on the left as I do on the right, and I have assigned all of my solubilities. All that's left is to break my aqueous substances into their ions and see which ones don't change. So let's see, this first one here. So I will have an iron ion and my 6 acetates. Remember, when writing a complete ionic equation, you need coefficients and charges. Make sure you multiply coefficients and any subscripts, like with the acetate. Next is my ammoniums. Then my oxide. That took care of the left side. On the right, I cannot change that solid. And my ammonium, acetate. Alright, if it changes, I want to keep it. If it doesn't change, I don't care. So let's see. Iron, ooh, that changed. Acetate, nope, didn't change. Spectator ion, do not care. Ammonium, do not care. Oxides, so all that's left is my iron and my oxide, which come together in the proper ratios to form my iron 3 oxide. Notice the charges, the coefficients, all come together to make a compound. This complete ionic equation here, if you don't need that to get to this space, don't feel like you have to do it, only if the problem requests it. Do you have to do this big long thing? So let's try one more. I'm going to go through this one a little bit faster because I am rapidly running out of time. First, translate. Magnesium sulfide reacts with cobalt. Charges go up high. Iodide, whoop, that doesn't equal 0. Magnesium with his 2+ is going to go with my iodide. There we go. Cobalt goes with the sulfide. So I did that really quickly. This is a double replacement reaction. I know that because I have 4 different ions. They switch places. Make sure you put a positive with a negatives. Subscripts are determined by the charges of the atoms involved in the compound, not by what was on the left. So don't think you have to carry a subscript across. If it does coincide, that is purely coincidence, I assure you. Let's balance this thing. Let's see, 1 magnesium, 1 magnesium, 1 sulfur, 3 sulfur, 1 cobalt, 2 cobalt, 3 iodide, 2 iodide, and to balance, let me see. Right off the bat, I notice here that I can't multiply any of those to get to either of those numbers. So I'm thinking I'm going to have to go to 6. So I'm going to start there. If I put a 2 here, that changes me to 2 cobalts. Ooh, that was a good thing. And 6 iodides. Over here, if I put a 3 there, that knocked my magnesiums out of kilter. But it did give me my 6 iodides, 2 cobalts, always a good thing. So what if I put a 3 over here, 3 of those, 3 of those? Hey, look at that. All balanced. Now on to our solubilities. Magnesium sulfide, let's see, group 1, ammonium, nope. Nitrate, acetate, chlorate, nope. Metal and a halogen, got the metal but no halogens. No sulfates, none of those bad boys. Sulfide. Sulfides are insoluble, but there's that magnesium. So this is an exception to sulfide's rule. That is, in fact, aqueous. Cobalt 3 iodide. I say, way too much. Rule 1, nope. Rule 2, nope. Rule 3, halogen and a metal. And this time, I have the halogen. Next, magnesium iodide. Group 1, ammonium, nope. Nitrate, acetate, chlorate, nope. Binary of halogen with a metal. Yay! And last, sulfide. I'm just going to jump down here. Sulfides are insoluble, and cobalt is not one of my exceptions. There is my solid. So a quick shortcut. Because I see that this is my solid, that tells me that the only ions that are going to change are the ones involved with that compound there. So I know that it took 2 cobalts to put that together and 3 sulfides to put that together to get my cobalt 3 sulfide. So that's a quick and dirty way. If they didn't require to do the complete ionic, let's buzz through the complete ionic here real quick. Hopefully I have enough time. 3 magnesiums and 3 sulfides. See, there's my 3 sulfides. 2 cobalts. Oops. There's my 2 cobalts. 6 iodides. Almost messed that up there. 3 magnesiums, 6 iodides, and my cobalt 3 sulfide. So if it has the AQ, you do get to break it into its ions. Check in for spectators. Let's see. Magnesium, spectator, sulfide changes, cobalt changes, iodide does not. Hey, look at there. It helps if I write my S capital. Oops. I just can't write today. I apologize. And look at there. My same 2 ions and my same relationships are coming together to form that solid. So there's 2 more examples for you in dealing with net ionic equations. If you're still having some difficulties, leave me a note down in the comment section below, and I will try to get back to you as soon as possible to clarify anything. So happy balancing!